In question number 31, a system of charges given having plus 2 coulomb, plus 5 coulomb and minus 3 coulomb charge. We want to find the net flux emerging from the system. Flux is given by Q enclosed by epsilon naught by Gauss's law. Here Q enclosed will be plus 2 plus 5 minus 3. So Q enclosed is 4 divided by epsilon naught. Value of epsilon naught is 8.854 into 10 power minus 12. So Q enclosed will be 4.5 into 10 power. So flux will be 4.5 into 10 power 11 Newton meter square per coulomb. Here modify the first option. First option should be 4.5 into 10 power 11. So option 1 is correct option. In question number 32, we want to find the magnitude of electric field on the surface of a sphere of radius r and surface charge density sigma. The electric field on surface of sphere can be given by sigma by epsilon naught. Here note that it is independent of radius r. So option 1 is correct option. In question number 33, the electric flux entering any closed surface is given phi1 and leaving the closed surface is given phi2. We want to find the electric charge inside the surface. According to Gauss law, phi total is equals to Q enclosed divided by epsilon naught. So Q enclosed is equals to total flux. Here, as per sign convention, flux entering is taken negative and flux leaving is taken positive. So Q enclosed will be phi2 minus phi1 into epsilon naught. So option 1 is correct option. In question number 34, a charge Q is placed at the center of open and cylindrical vessel. So charge is placed at this point. We want to find the flux of the electric field through the surface of the vessel. Here the flux from the curved surface will be 0. So flux will pass only from this surfaces. As area of this circular surface is same, flux will also be same. So we can write phi1 plus phi2 is equals to Q by epsilon naught. But phi1 is equals to phi2. So we can write 2 phi is equals to Q by epsilon naught. So flux will be equal to Q by 2 epsilon naught. So option 1 is correct option. In question number 35, the inward flux is given 8 into 10 power 3 Newton meter square per coulomb. For inward flux, the sign convention is negative, and the outward flux is 4 into 10 power 3 Newton meter square per coulomb. We want to find the total charge enclosed. So phi total is equals to Q enclosed by epsilon naught. Here Q enclosed can be given as 4 minus 8 into 10 power 3 into epsilon naught. So Q enclosed will be minus 4 epsilon naught into 10 power 3 coulomb. So option 4 is correct option. In question number 36, a cylinder of radius r and length L is placed in a uniform electric field parallel to its axis. We want to find the flux from the two flat surfaces of the cylinder. That means we want to find the flux through this surface. For this surface, electric field is along this direction and area normal is perpendicular to it. Flux is given by E dot A. Here angle between area vector and electric field is 90, so flux will be 0. So option 4 is correct option. In question number 37, a cube is arranged such that its sides are along x, y and z axis respectively. Let's say this axis is x, this axis is y and this is z axis. One of its corner is situated at the origin. The length of each side of the cube is 25 centimeter. The electric field component are Ex is equals to 400 root 2 Newton per Coulomb and Ey and Ez are 0. We want to find the flux coming out of the cube from one end. Here along y-axis and along z-axis electric field is 0. So E is located only along x-axis. So flux is related only to this surface, the surface which is perpendicular to electric field, so that the area vector will be along the direction of E. So flux coming out from this surface can be written as E A cos 0 degree. Electric field is 400 root 2. Area is 25 into 25 divided by 100 into 100 because it is given in centimeter. Simplifying this, we will get phi is equals to 25 root 2 Newton meter square per Coulomb. So option 1 is correct option. In question number 38, three different surfaces are given, A, B and C. We want to find the total flux associated with the surfaces. In first case, the flux entering and flux leaving will be same, so net flux enclosed will be 0. Same case with B, the flux entering and flux leaving are same, and same is the case with C. So for all the surfaces, flux associated is 0. So for A is equals to 0, B is also 0 and C is equals to 0. So option 1 is correct option. In question number 39, the surface charge density of a soap bubble of radius r and surface tension is T and sigma. Let's say this is soap bubble. The surface charge density is sigma. Its radius is r and surface tension is T. Here P is the excess pressure, that is P is equals to P in minus P out. We want to find the value of sigma. Soap bubble is positively charged, so the pressures acting on it will be in this direction. The pressure due to outer atmosphere, that is P out, and pressure due to surface tension will be acting inward. The pressure due to inside air will be acting outward, that is P in, and pressure due to this charges will also be acting in radially outward direction. Let's say this is pressure due to electrical charges. As soap bubble is in equilibrium, it is not bursting out, we can write P out plus PT is equals to P electrical plus P in, but P in minus P out is equals to P. So we can write P in minus P out is equals to PT minus P electrical charges. The pressure due to surface tension can be written as 4T by R, and pressure due to charge can be written as sigma square by 2 epsilon naught is equals to P. So sigma square by 2 epsilon naught is equals to 4T by R minus P. So sigma can be written as 2 epsilon naught into 4T by R minus P whole power 1 by 2. So option 2 is correct option. In question number 40, an infinitely long thin straight wire is given. It has uniform linear charge density lambda as 1 by 3 coulomb per meter. We want to find the magnitude of electric field intensity at distance r is equals to 18 centimeter, that is 0.18 meter. The electric field intensity due to infinite line charge can be given as 2k lambda divided by r. So E will be 2, k is 9 into 10 power 9, lambda is given 1 by 3, and r is 18 centimeter, that is 18 by 100. Simplify this, we'll get answer 0.33 into 10 power 11 Newton per coulomb. So option 1 is correct option. In question number 41, two concentric spheres are given of radius A and another of radius 2A. Charge Q is placed at their common center. We want to compare their flux. Let's say flux phi 1 is coming out from sphere 1 and phi 2 is linked with sphere 2. Here phi 1 will be equal to phi 2 is equals to Q by epsilon naught. Here flux is independent of surface area. So option 3 is correct option. In question number 42, we want to find the number of electric lines of force originating from a charge of 1 coulomb. The number of field lines, that means flux is equals to Q by epsilon naught. Here Q is 1 coulomb divided by epsilon naught is 8.854 into 10 power minus 12. Simplifying this, we'll get phi is equals to 1.129 into 10 power 11. So option 1 is correct option. In question number 43, a cube of side L is placed inside a uniform electric field. The electric field is given by E I gap. We want to find the net electric flux through the cube. As it is placed in uniform electric field, the flux entering to cube will be equal to flux exiting the cube. So total flux will be 0. So option 1. In question number 44, we want to find the total flux linked with the unit negative charge. The flux linked with negative charge is directed radially outward, and its value will be Q by epsilon naught, that is 1 by epsilon naught. The flux will be 1 by epsilon naught outwards. So option 1 is correct option. In question number 45, electric charge is uniformly distributed along a long straight wire of radius 1 mm. The charge per unit centimeter is Q. Another cylinder of surface of radius 50 centimeter and length 1 meter symmetrically encloses the wire as shown in figure. We want to find the total flux passing through the cylindrical surface. Here total flux is equals to Q enclosed by epsilon naught. Here the charge per centimeter is Q. So charge per meter will be equal to 100 Q. So flux will be equal to Q enclosed, and Q enclosed in 1 meter length will be 100 Q divided by epsilon naught. So option 2 is correct option. Thank you.